Hey class, Mr. Mohiddin here with a example video on how to evaluate definite integrals using the Fundamental Theorem of Calculus. So the basic premise is you take given a function who's being integrated from a to b, you find the antiderivative and you evaluate the antiderivative at b and at a, and you find their difference. So let's go ahead and dive in. The antiderivative of 3 over x should be 3 ln of x, absolute value. So I would have the antiderivative be 3 ln of x. Now often you'd have plus c here, but as you'll see in just a moment, the c will actually fall out, and it won't actually be necessary. So evaluated from 1, and that's 6. So the absolute value here, make sure these are going to be enterable, or in the domain of ln of x. So that would give me 3 ln of 6, and this will give me 3 ln of 1. The absolute value here wouldn't really be necessary. Subtract, and I get the answer. So here I'll need a calculator to evaluate those because I don't quite know those logs. 3 ln of 6 minus 3 ln of 1 gives me 5.375. To check, I'm going to use my calculator here is a little bit older than yours, but Math 9, 3 over x, integrated with respect to x, from 1 to 6, gives me the very same value. So there you go. Next I have a trig example here for us. So the integral from pi over 2 to 2 pi of the sine of theta d theta. Sine is nothing's antiderivative, but cosine derivative is sine, so negative cosine of theta should work out from pi over 2 to 2 pi. Just check cosine becomes negative sine, the negative here cancels, giving us just sine. So evaluating here, I'm careful with my negative signs, SOGN sign. Negative cosine of 2 pi, we'll be plugging this in, and then negative cosine of pi over 2, plugging that in, and I'm going to subtract those values. So here's my cosine wave. It's the shifted sine wave. This is 2 pi, and this is pi over 2. So this is pi right here, and then this would be pi over 2. Let me make that a bit bigger so we can see. So this is 2 pi, this is pi, pi over 2, and 3 pi over 2. So cosine of 2 pi, according to this, is 1. So this negative out here makes that a negative 1. This minus comes from the Fundamental Theorem of Calculus. Negative cosine of pi over 2, well, it looks like cosine of pi over 2 is 0, so negative 0 is still 0. Negative 1 minus 0 is just negative 1. Let's check. I want to make sure my calculator is in the right mode. It is not. Radian mode. The integral of sine of variable with respect to that variable from pi over 2 all the way up to 2 pi gives me negative 1. Finally, I have a power rule example here. By dx. Integral from negative 4 to negative 1 of 4 over x squared. Well, that's really this problem here in disguise. Okay. Well, here I'm going to use the power rule, so that's going to be up by 1, makes that a negative 1, and then dividing by that would be 4x to the negative 1. Just checking, I'll bring this down, cancels, bring this down by 1, and gives me negative 2, so very good. To myself like this. So here we go. I'm going to rewrite that a bit to make it a bit easier to enter. This is really negative 4 over x, using the properties of negative exponents. Negative 4 over negative 1. Go ahead and plug these in. Negative 4 over negative 1 minus negative 4 over negative 4. This is f of b, and this is f of a. Negative 4 over negative 1 is positive 4, minus negative 4 over negative 4 is positive 1. 4 minus 1 famously is 3. So let me check that value. Math 9, 4 over x squared. With respect to x, from negative 4 to negative 1, should be 3. Enjoy.